Everyone, and welcome. Today we are going to talk about getting started with MATLAB. Let me share my screen with you so we can get started. So today we will work with MATLAB. I will give you an overview of how MATLAB works, and I will teach you the basics that you need to get started with graphing with MATLAB. And we will round out the day with writing some scripts and putting together some of that information. We'll also have information available for you to work on after you've heard this presentation so that you can practice the things that we've learned together. So taking the first look at the MATLAB GUI for those of you who have not yet used MATLAB. MATLAB has a lot of wonderful features that you can take advantage of. It has a high level of programming language for scientific and engineering computing. It is a well-used package in many fields. It has excellent graphics, has built-in apps for curve fitting, signal analysis, and discipline-specific tasks. Boxes allow you to add on functionality for certain disciplines. Their interfaces with C, C++, Java, Python, SQL databases, Excel, and various devices. There's also a GUI for workflow integration. Immediate uses for MATLAB involve carrying out calculations, working with vectors and matrices, automating data analysis with scripts, and making graphics for your poster. So we'll talk about a look at the GUI, vectors, 2D plotting, matrices, solving linear equations, 3D graphs, and programming in M files. In particular, we will look at data analysis from Excel spreadsheets. So the setup of the MATLAB GUI involves these major areas. This is what MATLAB looks like when you download and install it on your computer. Note that it's available for all Wesleyan students from the IT web department website. This is your command window where you'll be typing information. This gives immediate feedback when you press return. This is your working directory. It shows what files and folders are already available. This is a useful way to link to your current scripts and so forth and load them into your actual work environment. This is called your workspace, and it shows your current variables that are available. Let's start off with MATLAB as a calculator. What you would do is you would simply type in some math and press the enter, and answer will report back what the solution is. There's a variety of MATLAB functions that are available. You can see that there's regular 4 functions are available that we're used to using. We also have power, exponentiation, and the square root. There are many other additional functions, including those that you're familiar with from trigonometry, and also log, max, min, and many, many others. There are also predefined variables in MATLAB that are useful to be aware of. The I and J are for an imaginary, INF is for infinity, NaN stands for not a number, and PI stands for pi, the familiar 3.14. There's also a variety of useful commands you should be aware of as you're getting started with MATLAB. You can use the up key to recall previous commands in order from the most recent, so you can go up and select them and then use that. The command CLC is going to clear the command window, and the command clear will clear all the variables in the workspace. Control C will abort the MATLAB computation. This is very useful if you manage to create an infinite loop. You can also access the help directory by typing help followed by the command that you are looking for. If you don't know the exact name of the command that you're looking for, you can use the look for command, and that will prompt you with some options that it thinks is similar to what you're trying to do, and then you can select one. This is a view of the MATLAB homepage on the web. They have many wonderful videos available. So if you are interested in expanding your knowledge of MATLAB, I highly recommend spending some time working with the MATLAB website. Vectors and matrices in MATLAB. So MATLAB, in fact, actually stands for Matrix Lab. And so the formulation of all the information that's in MATLAB is in fact actually a matrix. Notice that a vector is in fact actually a subset of a matrix. And so we'll start off by talking about vectors. And many of these things are going to also carry over into matrices. So a row vector is an array in dimension 1 by n and can be created in MATLAB. A listing number is separated by a space or comma within the square brackets like this. The colon notation is a shortcut that exists in MATLAB for creating row vectors, and this is basically going to allow you to create a vector series of numbers that are either increasing or decreasing. So we can do this syntax: start value, increment, and end value. Here's an example of using that notation here. A column vector can be created putting colons in between. So for example, what we can, semicolons. So you see that we can type this similar to how we typed our other vectors, but when we press the enter, we see that this becomes a column. You can use vector transposition in order to convert from one orientation to the other. So Q prime, we see, has rotated the the vector. Okay, we can also do vector addition and subtraction. Here is an example. We have S and Q. We can do vector addition and store this into Z. So here we have S plus Q. This will pairwise add the numbers and then they get stored. As you might expect, vector subtraction works quite similarly. Here we are subtracting the scalar 3 from the vector S. We can also do vector multiplication as the dot product. So the dot product multiplies a vector by another vector of the same dimension or by a scalar by element-wise multiplication. The dot product is indicated by the dot star symbol as seen here. Vector multiplication is the inner product. So this is a quick review for those of you who may be a little rusty on your math skills. This is how the inner product is computed. It's indicated as A dot B for the inner product. And A dot B is defined as the summation of I to n, the number of entries you have, AI, BI. So they're multiplied together, which will equal to C. So here we have an example of how this would look if you did it in MATLAB. You can also do element-wise division. What this will do is it will divide each element by some particular number. It's possible to divide a vector by a scalar through element-wise division. This is a summary of the array operators available in MATLAB. Notice that they all begin with the dot notation. So dot star, dot division, and so on. We can also define matrices in MATLAB. So a matrix is essentially several row vectors. So here we have a row 1, 2, 3, and then we have the semicolon to go down to the next line like we had in the column vectors. Then we have 4, 5, 6 in the next row and 7, 8, 9. So when we press enter, we see that this format is shown. There are individual elements of a matrix which can be defined by writing a shortcut. We can use sign of 0. We can also use the colon notation that we mentioned before. So here's an example using that notation. So it's going to fill out the graph for us, which we see, fill out the matrix for us as we see here. Elements of an R-defined matrices can be pulled to create new matrices. So for example, here what we're doing is we are taking subsets of pre-existing matrices in order to get a new matrix. We can also modify existing matrices. This can be done by assigning values in a particular position. So here's a C, this is a matrix, and this 2, 5 is accessing a particular position. And being equal to 6, what this is doing is reassigning the value. So this assigns the value 6 to the position in the second row and the 5th column. Notice that what's happened here is that the dimensions have needed to increase in order to have this position exist. This is why the dimensions of this matrix are different from the original The zeros matrix C can now easily be redefined by assigning the position to a new value. So you see that what we can do is expand the matrix by identifying a position that's greater than what already exists, and then we can fill that in with a new value if that's what you'd like to do. Next, let's talk about 2D plots in MATLAB. So, plotting vectors. Here's an example of some data, and we may wish to plot this data. Note the use of this colon here to automatically generate the x values. Another thing we may wish to do is to actually plot some functions. So, for example, the scripts on the left are illustrating how we might do that. We see that here we have some graphs of sine and related graphs over here. So what we've done here is we've defined x to generate the x-axis, and then we have 4 sets of y values. So these are some variants of the sine graph, and then we use the plot command in order to generate the graphs. Here's some information that is customizing that plot. Here we are going to use plot of sine functions as the title, which appears up here. We have an x label and a y label, which are appearing respectively on the axes. Finally, we also have a legend here, so the legend keyword causes this legend to appear. And here we're able to actually put in some text to define what we've plotted on the graph. And then the plot command will actually render the graph that you see. Next, we have the plot attribute summary. These are the symbols that can be used in order to customize your graph. There are also additional plot types available. You can access these by using the strip labeled as plots. Many of the plots operate in very similar ways and use the common syntax that we've just talked about. This makes it very easy to select a different kind of plot and to use that in your scripts. These are some commonly used 2D plot commands. The command is listed on the left, and the plot generated is on the right. We can see that there are many different kinds of plots. So, for example, you might have a 2D line plot, which you've looked at, plots for functions, bar graphs, horizontal bar graphs, histograms, world area, 2D plots, pie, scatter, contour plots, and log-log scale plots are some examples of what you can easily customize using the available pull-down menu or that strip in MATLAB. Let's talk about matrices. So there's a little bit more information that will be useful to know about the matrices. We can transpose matrices using the prime, similar to what we saw before. Obtaining a matrix dimensions may also be something that you wish to do. So we can use the size command in order to do this. This means that there are 3 rows and 3 columns in this matrix shown here. There are a number of built-in elementary matrices that can be useful to use. The command I generates the m by n matrix with 1 on the main diagonal and 0s everywhere else, also known as the identity matrix. In will make a square matrix. 0s will make a m by n matrix of 0s. 1s with m by n will do similar with 1s. You can extract the diagonal of matrix A using diagonal, and random will return an m by n matrix of random numbers. You can do arithmetic operations on matrices much as we can do this on vectors. So for an example, we can add 2 to each element, we can subtract 100. From every element, we can multiply each element by 10, and we can divide each element by 0.5. Let's take a look at 3-dimensional graphing. This is an example of how you can graph a sphere. Here we are setting up x, y, z equals sphere of 20. This is 3 21 by 21 matrices. And then we're going to fit the surface to that and display the sphere. This is what is shown here. We can also graph cylinders, and this is how cylinders are displayed. Cylinders are going to allow for more manipulation than spheres because we can change the shape of the walls. You can plot a cylinder with nonlinear walls using the code below. So here we have T and R being set up. This is basically using the parametric notation. X, Y, Z equals cylinder of R, which is going to create the cylinder, and then we fit a surface over that, which creates these disks. And then we can do the shading by interpolation to create the color gradient shown here. We can also graph using parametric equations. So this is an example of a parametric equation. Recall from your math classes that this is going to be the sum of two different equations. So here's an example, x cubed minus y squared. So first you have to define x and y. So here are some definitions of x and y. Then what we're going to do is we're basically going to do the mesh grid, which is going to use the vectors x and y to create the rectangular grid. Then we're going to calculate the z-axis, and that is going to give us the three-dimensionality. The next thing we need to do is we need to create the surface, and then we need to shade the surface using interpolation, as we did for some of the other graphs. There are a number of basic 3D plot commands that are available. As with the other plot commands, these are going to be in a general format that will allow you to easily move between one and the other. So once you master doing one kind of 3D plot, you'll be able to quickly go in and make another kind of a graph if you choose to do so. Next, I'd like to talk about importing data from an Excel file. This can be really useful if you have data from some other application and you wish to automate your processing using MATLAB. So data from Excel can be read into the MATLAB using information that is obtained in the Excel spreadsheet. There are a few things you need to be aware of in the Excel spreadsheet that will be useful for actually writing your code. First of all, the name of the file, which is listed at the top. It will also be important to know where it's stored on your computer, as you'll need to write the complete path to the Excel file that you're trying to open. This box here will show the current selection. Notice that here we have the cursor on this box here, which is in position A1. A stands for the columns, and the columns are given by the letters going across the top. The row numbers are given down here. A range, when highlighted, will display a range here in the current selection. XLS read is the key command that's needed in order to read the information into MATLAB from an Excel spreadsheet. What you need to do is specify the path on your computer to the location of the Excel spreadsheet. To read this data from the spreadsheet, you'll need to provide the column and cell numbers of the spreadsheet to read. In order to do this, you can highlight that information and look in the boxes, as I showed you in the previous slide, to identify which part you want to analyze. Once the data is read into MATLAB, you can work with it just as you would with any other vector matrix, depending on the dimensions of the data that you read in. Here is some sample syntax. You would have a variable, and then you use the XLS read. You're going to provide a path in quotes, and then you need to tell the column and cell number to column and cell number of where the data is located. This will then load that information into the variable that you define. Here's an example of setting up a variable using the XLS read. Here is a path to a directory on a student's disk, and this is going to use a particular range from E2 to E121 from that spreadsheet. The next thing we're going to look at is how to do programming with MATLAB. So it's useful to be able to type things into the command line and get an immediate feedback. However, as you start doing more sophisticated things, you may wish to do that multiple times, and so it will be important to understand how you can actually save your data and recycle scripts that you write. Here's an example of creating a script file. In MATLAB, script files are called M files. We're going to use the new script button to create a new script, and then what you'll see is that an editor will appear, and you can type your new script into the editor. As mentioned, the M file is the name for scripts. After you've selected a new function file, you'll see it also appears in the editor, but it looks slightly different from the new script file. See, this is how your script file will look. This default setup reminds you of the basic parts of an M file, the function definition line, which defines the function name and the number and the order of input arguments. Here is the information. This is the keyword function definition. And then here is where the output arguments go. And then we're going to have the input arguments here. And this is any variable name. When you're going to save your mfile function, you must save it with the same name as your function's name. Otherwise, it will be difficult to access it and may not be recognized. To execute your function for x equals 2, meaning that 2 is going to be your input, you will use basic algebra. So here's some function name, and then 2 will be the input, and you type this into the command window. This will call your mfile and will cause it to be executed. The output will be reported on your screen. It's useful to note that the function files can be summoned within your script as long as they are both saved in the same folder. This allows you to execute the same function for different inputs over and over again within a script without having to type out the name of the function each time. This can be very useful to write mfiles in order to do things such as process data that is in spreadsheets, which is what you'll be working on as one of your exercises in today's tutorial. So that brings us to the tutorial. When you work on today's lab exercise, you will learn the basics of working with vectors and matrices and practice with some hands-on examples. You'll be creating some plots, you'll be creating some mfiles, and you'll also extract some data from an Excel file and perform calculations and make some graphs. This will hopefully be a useful template for other work that you may wish to do and will hopefully help you to automate some of your lab work. We hope you enjoyed today's lecture and found that helpful. I would like to invite you to please have a look at the exercises that I prepared for you, and be sure to also download the Excel spreadsheet that goes along with today's exercises. Thank you very much, and we hope to see you in future editions, other labs and exercises for you to enhance your summer research. Bye-bye.